Good evening. Welcome to BZIGN Talks Day 2, organized by BZIGN Club, BIMLABS as well as BIM Studio. I'll be speaking about the topic Parametric BIM, energy efficient from concept to design. I'm BOVAS, technical engineer at BIMLABS. You can find me on LinkedIn or contact me through Gmail in the displayed addresses. Like I mentioned, our topic today is Parametric BIM, energy efficient design. To give you a quick rundown, our topics about a coordinated and progressive energy optimization effort. Progressive as in the sense that the process or optimization starts from the conceptual stage and continues till the detailed stage. So we'll be using or integrating several modern tools available for building information modeling process, namely Autodesk Revit, Autodesk Insight 360, as well as Dynamo, the visual programming software from Autodesk. So it will be a fusion of three modeling as well as analysis softwares or tools. Four, in fact, considering that Formit 360 can also be used in the initial stage or the conceptual design stage. Our agenda today starts with the objectives and summary of this particular topic or project. I'll explain that as well as the methodology and software used in this particular workflow. All the softwares, as I showed earlier, I will be explaining those as well as the BIMLABS advantages, what we have to offer you, as well as a question and answer session at the end. So please save up your doubts to the last of the session, and we can have discussions on those questions at the last. So our objectives is to develop a workflow to connect BIM parametric design tools, energy simulation tools, and optimization algorithms for the customization of individual building components or the whole building form in order to reduce anticipated energy use. So we will be customizing the building as a whole or as a part in order to reduce energy use or to optimize energy usage to the maximum possible with the available tools. The second objective would be to ensure that the design is sustainable in nature from the initial stages of design to the final stages as well. The final stages or the final objective would be the design of a kinetic facade system that adds to the energy saving effort of the workflow. It augments the existing energy optimization efforts and complements the changes accepted into the BIM design. As for a summary into the project, in parametric designing, a family or element is designed with a set rules and relations between the parameters to create instances. And these parameters may be linked or connected to factors that in our particular case relates to energy. So at the end, what we have with us is a responsive or intelligent building with components that can adjust themselves with the atmospheric changes or external factors. That, in a few words, is what parametric design is concerning our particular workflow. The methodology of this particular effort or workflow starts with a conceptual level climatic study on the considered project. The conceptual level design can be done in Formit Pro 360, and all the softwares will be explained briefly in the coming sessions or the coming slides. So after the conceptual design, the next stage would be to create an architectural model using BIM authoring tools. And in our particular workflow, it's going to be Revit, Autodesk Revit. And this particular model, architectural model, will be further analyzed using Insight 360, again, a cloud platform for energy analysis. And this particular cloud platform gives us design options for evaluating the building performance results and further optimizing our model. The next step in our particular workflow is creating a parametric facade component using adaptive component families and applying this particular adaptive components into our building using visual programming software and, or in this case, Dynamo. Without further delay, let's get straight into the heart of the matter. And the first tool is Formit Pro 360, which we will be using in our workflow. And Formit Pro 360, as some of you might be aware of, is a conceptual designing platform or which can be hosted on the cloud. It can be a cloud platform, and it has recently gained wide popularity due to the ease of design using this particular software. Other advantages of Formit Pro 360 is that the conceptual models created in this particular cloud platform is highly interoperable with Revit as well as energy simulation tools. It is also possible to conduct a basic climatic level studies or solar analysis on the conceptual design or the conceptual model created in Formit Pro 360. If I were to demonstrate it to you, this is the Formit Pro 360 cloud platform, wherein conceptual models are designed as basic geometry, surfaces, etc. And once you set the location of this particular conceptual model from this particular option, it is also possible to conduct a basic sun simulation or sun setting simulation to study the variation of shadows, as well as to analyze this particular conceptual model for the feasibility of solar panel application and similar applications. So this is Formit Pro 360, and there is also an available option which enables us to push this particular model into Insight 360, the upcoming tool in our workflow, which actually analyzes this particular model for energy optimization. This will be the first tool in our particular workflow, Formit Pro 360, for the conceptual level designing as well as climatic study. The next tool in our particular workflow is Revit architecture or Revit. And since I'm assuming everyone is familiar with Revit to some extent, I'm not explaining it in detail. Revit is a widely used BIM software from Autodesk, offering a wide range of or a wide array of tools and options for designing. The energy analysis settings can be found on the Analyze or Analysis tab and under the Energy Optimization panel. And once we specify the energy settings for this particular model, the next step would be to create an energy model from the existing architectural model. This is one of the most important steps, wherein the model we've created is divided into analytical spaces as shown in the figure. And this energy model can be uploaded into Insight 360 for further energy optimization and energy reports. It is also possible to conduct daylight or heating and cooling load studies using the systems analysis option in the energy optimization panel. The next tool in our particular workflow is Insight 360, which is again another cloud platform for energy simulation, which is also from Autodesk. And it's a cloud platform which gives us range-based energy reports for further optimization of our model, which will be clear as I demonstrate it later. And this particular platform uses ASHRAE and Architecture 2030 benchmarks for analyzing or rating our particular model. And parameters like HVAC, window to wall ratios, shading, orientation, and a host of other features or parameters are analyzed in Insight 360 using Energy Plus or DOE2 energy simulation engines. It's also possible to do solar analysis, heating and cooling loads, or conduct such studies in Insight 360. This is a basic interface or a view of what Insight 360 would look like. So this is what, or this is the interface of Insight 360. As you can see, there are several models that I've analyzed using this particular platform. This is a model that has been pushed from Format 360 or a conceptual at the conceptual stage. So our workflow starts from the conceptual stage and ends at the detailed design stage. So it's a progressive effort wherein energy optimization is done at each step so that maximum energy optimization or efficiency can be achieved throughout the design process. So when I said Insight 360 gives us a range-based reports, it means that if you're considering this particular parameter, that is the window wall ratio in the southern walls, it gives us a range-based approach wherein the variation of the window wall ratios and the effect it has on the energy cost. Insight 360 tells us what the energy cost is, because finally it all comes down to cost. And Energy 360 gives us an idea of how much the energy cost would be based on the existing design component features, thermal properties, and similar features. It's also possible to create scenarios or design options by varying the ranges based on our particular needs. So once we are varying this particular range, we can create scenarios and compare the models based on different scenarios and its corresponding performance. This is a model that has been uploaded from Format, while the next model that I'll be showing you has been uploaded from Revit. It is a detailed model. This is a sample model from Revit, and it's a detailed architectural model. And parameters like building orientation, window to wall ratio, the window shades, window glass, as well as similar parameters are displayed here on a range-based approach. And we can try varying these ranges and see what the changes in the energy cost mean would look like. So this is Insight 360, a cloud-based platform for energy analysis and similar purposes. So it's also possible to get reports on the lighting efficiency, daylighting and occupancy controls, plug load efficiency, HVAC, operating schedule, photovoltaic panel efficiency, and similar features. Further, from the options at the top, the visualize options, it's also possible to do a PV analysis wherein the model is analyzed for the feasibility of photovoltaic panels. Insight 360 also uses benchmarks, namely Architecture 2030 and ASHRAE. So it's also possible to optimize the models we upload into Insight 360 based on the features of this benchmarks. So if I'm selecting the scenarios or the settings to Architecture 2030 or net zero, Insight 360 optimizes our models so that the parameters are changed in a way that the minimum value possible for the energy cost is shown for each of the models. So the energy cost in the unit US dollar per meter square per year, these values are optimized based on the benchmark features or the benchmark guidelines given in Net Zero and Architecture 2030 guidelines. So that's about Insight, the energy analysis tool in our particular workflow. So once we analyzed or optimized the energy use in our particular project from the conceptual stage to the detailed stage using the tools Format 360, Revit, as well as Insight 360, the next option would be to augment the changes we've made using further design components and further and elements. So in now particular workflow, we'll be using kinetic facades for augmenting the energy performance, and we'll be taking the help of visual programming platform for doing so. Visual programming, as you might have heard, is graphical programming in the sense that one does not need to interact with actual textual programs to perform the function, but perform the function with graphical programmings wherein boxes and arrows can be connected and functionalized to achieve our particular purposes. Examples for visual programming platforms are Grasshopper, used in Rhino, generative components from Bentley, and Dynamo from Autodesk. So in our particular case, we'll be using Dynamo in our workflow. Dynamo is an open source project by Autodesk and developed by a team at Autodesk. It can be standalone as well as used in conjunction with Autodesk softwares to further extend the functionality of existing Autodesk softwares. It can be also used to set up project workflows for computational design in architecture and similar fields, also to introduce automation into AEC industry. Dynamo has recently gained wide popularity due to its intimate nature or connection with Revit and other Autodesk softwares. So we will be designing kinetic facades with the help of Dynamo, and this is an example, a Dynamo tower created with the help of Dynamo. And in this particular tower, adaptive components have been applied to the surface of this particular tower, which are kinetic in nature. They are connected or related to the external factors such as sunlight or the solar path, sun path, and the kinetic facades respond intelligently to the variation in the sun path. So these are other examples of kinetic facades that can be created using Dynamo. To give you an example, I'll be showing you what Dynamo can achieve with respect to kinetic facades. I'll show the results first and explain the process later. So what we have now is just a surface with adaptive components applied on the surface with openings created in the adaptive components and connected to a parameter. I've also turned on the sun path settings in Revit, and if I'm changing the position of the sun, you can find that the openings in the adaptive components also vary with regards to the position of the sun. So the adaptive components furthest from the sun have larger openings to let in more daylight, while the adaptive components in direct exposure to the sun closes or reduces their openings so that as minimum or the minimum amount of daylight is let through. It will be further visible if I change the position of the sun to the extreme. In this case, the adaptive panels which are in direct exposure or directly facing the sun have smaller openings or minimal openings as indicated by the color coding. The red means the strongest exposure while green means the lowest exposure. So the ones at the end or the furthest from the sun have the larger openings, while those directly exposed to sun have the lower openings as well. So this can be, or this example is a basic example of what kinetic facades do. I will also explain the reasoning or the visual programming logic behind this particular process. So this is the interface of Dynamo. So I won't be explaining it in detail. I hope you are familiar in some way with Dynamo. What I've done in this particular Dynamo script is import that particular surface created in Revit into Dynamo, applied adaptive components onto the surface using a particular node in Dynamo called adaptive component by points. And I've also represented the position of the sun in Revit using some nodes known as sun settings.current, sun settings.altitude, etc. in Dynamo. And the next step would be to create a distance-based relation between the position of the sun and each of the adaptive panels. It can be represented by these lines. So the dot or the origin of these lines in this case would represent the position of the sun, while each of the lines represents its position with relative to the each of the adaptive components. So longer the distance is, larger the opening would be, and the shorter the distance is, the smaller the opening would be. So this is a distance-based relation between the position of the sun and each of the adaptive components. It's also possible to define other relations between the position of the sun and the adaptive components, namely incident angle-based relations, etc. So this is the logic behind this particular visual programming script. It's also possible to color code the adaptive components using certain nodes as evident in Revit. One can also turn on the shadow option in Revit for further proof of the effectiveness of this particular workflow. Lesser daylight is allowed through the adaptive panels with the smaller openings, while large amount of daylight is allowed through the adaptive components furthest from the sun. So this is a basic example of what kinetic facades do and their important function in our particular workflow. We optimized our particular model from the start, from the conceptual design itself, using Insight 360 and Format 360. And after the conceptual design, we developed the model further or detailed the model further using Revit and analyzed or optimized the model again using Insight 360. And considering the design options, we made the design as energy efficient as it could be. And the last step was to augment our particular model or efforts we made in regards to energy optimization. We augmented these efforts using kinetic facades and visual programming. So that's all about the workflow we are using in this particular project. So links for feedback of this particular session will be shared in the chat box. Please do go through it. And we also offer a workshop for this particular topic. And the topics covered in the workshop would be energy analysis, Insight 360, and Dynamo. The workshop would be of a duration of 3 days of 2 hours each and starting on 11th November. The fees for the workshop will be rupees 1,000 for the 3 days. And upcoming talks on BZIGN talks is BIM for facilitating construction safety at construction sites, making use of Synchro software from Bentley, wherein we can identify or prevent accidents even while in the design stage of the building itself, as opposed to the accident prevention once the construction has actually started. I would also like to introduce you to the BIMLABS BIM community, where anything related to BIM is encouraged and promoted, where you can learn BIM and learn new technologies as well as tools in the field of BIM. Free trainings and seminars are also available, as well as challenges, knowledge evaluation, and placement assistance. I welcome you all to this particular community and encourage you to look into it. I would like to thank you for cooperating in this particular webinar and participating as well. So if there are any particular queries or doubts regarding any of the topics covered in this particular session, please do ask me and I'll field them.
Hi, sir.
Hello.
Hi, sir. This is Bhupati.
Please do ask questions.
Yeah. Format Pro 360 app is like Rivet. It's similar to Rivet, right?
Format Pro 360 can be used for conceptual design.
Okay, it's not for designing or detailing modeling, right?
It cannot be used for advanced detailed designing.
Okay.
Similar
You
to
can
Revit.
do basic design in
Yeah.
Format Pro 360.
Yes.
Okay, sir. Thank you.
Okay. It's similar to SketchUp,
Okay.
wherein basic
Yeah.
designing can be done. But in our particular case, the advantage is that the Formit 360 conceptual design can be pushed into inside 360 for energy analysis in the conceptual stage itself. Furthermore,
Yeah, more
basic
effective than we do than in Rivet, right?
in the for the case of conceptual design, that's right. But even in
Okay.
Revit, we can upload the same model to inside 360. We have options for that.
Okay. You can use either of the both.
Yeah, but the recommendation or what we are intending in this particular workflow is that we will be optimizing the energy throughout its design. That means we will be optimizing the model in the conceptual stage and throughout the design process.
Okay.
That means if you are optimizing it only in the conceptual stage, in the later stages, changes may be adapted or assigned to that particular model. So the energy analysis done on the first try or on the conceptual stage might not be
Okay.
effective for the detailed model. And if you
Yeah.
are not optimizing it at the start, at the
Okay.
conceptual stage and optimizing it only at the last stage, it might not be as effective because a lot of changes might have to be made with regards to energy efficiency. You might have
Okay.
to make a lot of changes. So it's recommended to make energy optimization or adapt energy optimization throughout the design stages.
Okay. It can be seen through Format 3 Pro 360.
Yeah.
Okay, fine. Thank you, sir.
All right. The option for
Hello,
yeah.
everybody. Please check the chat box. I shared all the links for you.
Are there any other doubts regards to this particular session or any of the softwares involved or the workflow involved?
Can I get to know the major use of Dynamo?
Yeah. So Dynamo can be used as a standalone software as well as it can be used complementing Revit.
Okay.
The uses of Dynamo can be that it can be used to develop or create project workflows, and it
Okay.
can be also be used for computational designing, wherein we define mathematical relations between geometries and data so that computational designing can be done. Also, it can be used to automate repetitive and tedious tasks. For
Okay.
example, large amount of data or for sheet creation, for schedule creation, as well as for creating columns out of CAD files, walls out of CAD files. So many tasks can be automated using Dynamo. Also, if you're further inclined or technically inclined, you can also use packages with Dynamo, for example, or namely the Firefly package, wherein you can connect Arduino. Are you familiar with Arduino chipboards?
No, sir.
So you can connect those and actually work out how kinetic facades work. You can actually create them.
Okay.
And several other packages also exist which can extend the functionality of Dynamo further.
Okay.
You can do energy analysis in Dynamo. There's a lot uncovered or undiscovered in the case of Dynamo. It
Okay,
can.
so I don't know about Dynamo. That is the reason why I asked that question.
Okay, sure.
Okay, sir.
Are there any other doubts? Further doubts? So I would like to thank everyone for attending this particular session and cooperating. Please go through everything I've mentioned and contact us with regards to any doubts you have for the workshops as well as the BIM community and this particular workflow. Also, please do attend the upcoming session on BIM for facilitating construction safety at construction sites. So thank you for attending.